Hello, this screencast will help you to complete this SWA-F from Module 4, how to create and describe a graph. So first of all, you're going to need the sample data. Um, the sample data is an SPSS file, so you need to make sure that you have SPSS on your computer and also that you are logged into the VPN client. Um, Here's how I do it. I am connected already. On your computer, however you connect to the VPN, the Cisco AnyConnect host, just make sure you're connected. Then you can just click the link to this file. It's downloaded to my computer. I'll try to move my screen so you can see it. And now, because I'm connected to the VPN client and I have SPSS on my computer, it will just open up for me. Okay, so once you have the data open, you will notice that it opens directly to the data view, and we have a bunch of data in here. We have gender, age, GPA, practice test group, feedback group, test score, social media use, caffeine, parenting styles, all these numbers. Well, what the heck do these numbers mean? Some of these numbers in here are independent variables and some are dependent variables. When you run an analysis, you have to pick only one dependent variable, and you need two independent variables, right? The two independent variables that you manipulated in your study. So the purpose of this exercise is to teach you how to analyze the data for your study. So let's focus on that factorial design. Now, how do I know what are the independent and the dependent variables? Like this activity, SWA-F, is just saying pick any two variables and analyze them, right? So what should I pick? Well, if you click over here on variable view, now it gives you a little bit more detail. We see the same names that were in the data view columns, right? Gender, age, GPA. They're back here again. They're all under name though. So these are the names of my columns. I have a bunch of information here, whatever. But notice now, I've already cleaned this data and given it labels. We'll do that in another activity with your own data once you collect it. But now we've got these labels, and you could spread them out. What the labels are, and this is so nice about using Google Forms and Excel, the Google form is going to export the label for you automatically. It's the question that you asked on the Google form, and then Excel will just be able to import it directly into SPSS. So these are all just the actual questions that we asked on the Google form. And now here's where I had to do some coding of the data that you guys will do with your own data. So notice here I have value options. Under gender, I had two options. If I click this values button, I've already coded it to give it the values. In my data set, I called females 1s and males 2s. What does that mean? Well, it means when I go under gender, I can't analyze male, female words, right? Or M's and F's. I need numbers. So these have already been recoded as 1s and 2s in my data set. And so the label is just explaining that for me. Let's look at how age is reflected here. Now, most of you will not be coded for age. Age will just be the actual number. Some of you, though, have coded age, like under 21 and 21 and over. For those groups, to give you an example, I went ahead and coded the data I had like that. So you'll notice there's labels there. What this means then is when you see these labels, these values in the value column, as opposed to none, the values are independent variables. Gender here is an independent variable with two levels, male, female. Age here is an independent variable with two levels, under 21, over 21. GPA is a dependent variable. It doesn't have any levels. It's just reported as the actual GPA. So this is a good dependent variable. I could manipulate age, I could manipulate gender, and measure GPA. Do younger people have better GPAs than older people? What about males, females? So that's what we mean by the independent and dependent variables. What are we manipulating? What are we measuring? So SWOT-F is asking you to pick any two independent variables and any one dependent variable. How do you know what to pick? Again, if it has a value, it's an independent variable. If it says none, it's a good dependent variable. But now try to think about your own data, and I know that you haven't worked with this particular data, but you could kind of guess at what the labels mean. For example, I have a label here called social media use. A lot of groups this semester are looking at social media use. I've coded it already into low, medium, high groups. I can tell right here because I know I've only got ones and twos and threes. And if I look in the variable view, it is labeled. And we can look at the values. 1 is 0 to 1 hours per day low. 2 is 2 to 4 hours per day medium. 3 is more than 4 hours per day high. So I'm going to go ahead and run a factorial ANOVA using two independent variables and one dependent variable. I would like to look at social media use and parenting styles. This is another labeled value independent variable with four groups. Here we have four parenting styles: authoritative, authoritarian, permissive, uninvolved. It's all already coded in the data for you. But I want to look at the impact of both social media use and parenting style on anxiety. And I have anxiety measured here as a dependent variable. Notice there's no value. It's just their overall total stay score. A lot of students in class are working with this stay. So I've already coded and added up total stay scores. Again, another screencast will show you how to do that. I've done that in this data set already. So these were the individual stay questions, like you rated on a scale of 1 to 5, or, I am worried, so forth. I added up a stay total score and converted that following the stay instructions to the stay score, etc., etc. Anyway, so all that's coded in this data set. But let's go ahead and do the analysis. So again, I'm interested in looking at social media use and parenting style on anxiety measured with the stay. I go to Analyze. I need to run the general linear model. To do the ANOVA, I want to run a univariate ANOVA. I click univariate, and now, oh my gosh, what is all this? Remember, you have one dependent variable. There's only room to put one. You can only analyze one at a time. So I want that stay total score. And if I did that too quickly, I scroll down, I find stay total, and I move it to my dependent variable. Why? Because I want to measure the effects of my fixed factors, my independent variables, on stress and anxiety. So now, what were my fixed factors? Remember, I was interested in social media use, and that's this question. I got to kind of look for it. How often do you use social media? And so I want to move that over. And I also wanted to look at parenting style, and I move that over. Those are my fixed factors, my independent variables. Remember, independent variables are factors. You have a two-way factorial ANOVA. Many of you have a 2 by 3 or 3 by 2. Okay, what else do I want to do for a quick refresh on SPSS? Because I know you haven't worked with it in a while. There's a bunch of things that I need to collect. I'm using an old version of SPSS. Most of you are going to have version 26, which is going to have an option here called EM means. For me, that's hidden under post hoc. So, and under options, I'll show you in a second. So, but click all of them. Click options, click EM means, and click post hoc, and you will eventually find the boxes that are looking just like this. So first here, I need to move all my factors over. So I select them both and I push them over because I need post hoc tests on all these. I'm going to pick one, Bonferroni. You can pick any, you could pick multiple. Bonferroni is a simple, easy, I know it's a t-test with a correction on it, so it's easy for me to understand the output. Anyway, so I click continue there. Again, if you have the option EM means, click that, move everything in the boxes over. You may have more options here. But anyway, also click this box options. Here's where you are probably going to see the EM means. So your EM means is going to have this top box. Click everything there, move it over, and then compare main effects. This is very important. If you don't do this, you're not going to get any of the means that you need to put in your graph. So display means, compare main effects. Now you need all of this other stuff: descriptives, effect size, power, and the homogeneity tests. You don't need anything else. But you could click it if you wanted, just make your output more complex. So once I have all that done, I click OK, and now I run my analysis. If I go to the top, because it starts you at the bottom, you will notice now that I have my between subjects factors. These were the two independent variables. I had social media use with 3 levels, low, medium, high, and I have parenting style with 4 levels. This is telling me the number of participants in each group. Nothing is 0, that's great. I have at least 5. I have 3 in this group, so that's good. But that's just telling me how many people used social media only 0 to 1 hours per day. There were 5. How many people used social media 2 to 4 hours per day? 10. How many people reported more than 4 hours a day? 11. Then how many people reported having authoritative parents? 8. Authoritarian, 8. Permissive, move this, 7. And uninvolved, 3. Now, what descriptive stats do you need? This is the matrix table that you need to put in the graph as I describe in the Excel graph video. So you want to create a table that looks just like this. Social media use across the top with 3 groups, parenting style down the side with 4 groups. Here's your mean authoritarian. No standard deviation because there was only 1 person in that group. If there is a standard deviation, add it, but these are all your means for each of the groups. Again, another screencast will show you how to look at that. But now, how do you interpret the data? Notice I did run an equality of variance test, and it is not significant. That's good. That means I have equal variance in all my groups. That's what I want. But here's the results of the ANOVA. I want to go through these because I know it's been a while for many of you. I only have about 2 minutes left, so I may talk quickly, but feel free to back up. If you don't remember how to read an ANOVA summary table, you ignore the first 2 lines, the corrected model, the intercept. This is reporting your main effect of social media use, the main effect of parenting style, and the interaction between social media use by parenting style. You also have the error and the total. You're going to need that for the degrees of freedom when you report your F values. So the main effect of social media use had 2 degrees of freedom. Why? We had 3 levels of social media use, low, medium, high. We subtract 1 to get the degree of freedom, 2. My F value is 20.413. That's huge. I am highly significant here. I have a 0.000 probability of making a type 1 error, right? Anything less than 0.05 here is significant. Here it's 0.000. I have very, very small probability of being wrong, basically. I look at effect size. I have an extremely high effect size, 0.73. This is a huge effect. What the heck did I measure, though? Think about the dependent variable, stress and anxiety. What this is showing me is that social media use had a significant effect on stress and anxiety. How, though? I don't know yet until I look at the actual numbers. That's why I need the graph in the means. It looks like the state totals were going up, 21s here instead of 15s for people who used more than 4 hours a day. And what that's telling me, is that in general, more social media use, more anxiety. Um, oh, my screencast, I believe my time is up. In case it isn't, I'm going to keep recording. Notice parenting style, there is no significant effect. My F is 0.405. My significance is much greater than 0.05. No effect size, no effect here. Interaction, also there is no interaction. The F is not significant. All right, I have another screencast that's going to show you how to interpret and graph this data. Any questions, just email me.